Welcome to my YouTube channel. So, in the previous lecture, we have discussed the non-existence of limits. Now we discuss double limit and iterated limit. So, double limit is this limit xy tends to x0 y0 f of xy equal to L. This is called double limit. In this case, if this is x0 y0 point and this is xy point, so from xy this approaches to x0 y0 by many points in this double limit. So it can approaches to x0 y0 through any path in this xy plane. So there are many paths through which xy can approaches to x0 y0 in the double limit. And in the iterated limits is defined as limit x tends to x0 first and then limit y tends to y0 f of x0 y0, and another is first y tends to y0 then limit x tends to x0 sorry f of x y this. So this is double limit and this is iterated limit, first and second iterated. So in this case, x tends to x0, y tends to y0. So in this case also, this point xy approaches to x0, y0, but through a simple path. So if this is a path x equal to x, this is x equal to x0, and this is x path and this is x axis y axis. So this is y equal to y0 and this is y equal to y. So in this case, first x approaches to x0, that is x approaches to x0, x approaches to x0, and then through which y approaches to y0. So in the first case, first x approaches to x0, that is through this path x approaches to x0, and then from here it goes to y approaches to y0, and ultimately xy approaches to x0 y0. And in this case, first y goes to y0, that is y equal to y and y equal to 0. So first this is y goes to y0, and then from here this x approaches to x0. So in this case, two particular path through which xy approaches to x0 y0, and here there is many path through which xy approaches to x0 y0. So now we discuss results. You can note down. Now we discuss the relation between double limit and iterated limit. If double limit x comma y approaches to x0 y0 f of xy exists and equal to L, then the iterated limits, that is limit x tends to x0, limit y tends to y0 f of xy, and limit y goes to y0 first and then limit x tends to x0 f of xy both equal and equal to this limit L, provided this limit and this limit exist, that is limit x tends to x0 f of xy and limit y tends to y0 f of xy exist. So this result tells that if the double limit exists and equal to L, then the iterated limit this and this equal and equal to L, provided these two limits exist. So this is the result, and we discuss some consequences from this result. So let's see. The result shows that double limit exists and equal to L implies that the first limit, iterated limit, both the iterated limits equal, same and equal to L, but converse may not true. That is, if limit x tends to x0 and limit y tends to y0, function f xy equal to limit y goes to y0, limit x goes to x0 f of xy, these are equal. So we cannot say that double limit exists. So these are only for two particular paths they are equal, but to exist double limit through any path through which xy approaches to x0 y0 be same, then the double limit exists. So if these two iterated limits are same, we cannot say that the double limit exists, because there may be some another path other than this particular path through which the limit double limit does not exist. You can note from this contrapositively. Contrapositively means if A implies B, if A happens then B, if this is true, then from this we can conclude that not B implies not A. That is, if B not happen, then we can say A also not happen. So contrapositively, if these limits are not equal, if we get these iterated limits are not same, then we say that the double limit does not exist. So now we discuss some examples regarding these results. First of all, limit xy tends to 0 0, x plus y and x minus y. This is the simple example. So we discuss the existence of this limit by iterated limit. First we find limit x tends to 0, limit y tends to 0. This is x plus y, x minus y. So from here we get limit x tends to 0, and if we put y equal to 0 here, we get x by x. So this is equal to 1. And if we find first y tends to y0 limit, and then limit x tends to y0 means 0, and x tends to 0, x plus y, x minus y, then we can find that limit y tends to 0, and this if we put x equal to 0 here, we get plus y minus y. So from here we get minus 1. So these two limits are not equal. So we get the result contrapositively, that if these two iterated limit not same, then from here we can say this limit double limit does not exist. So for this function x minus y not equal to 0, and now we discuss example 2. This is also limit xy approaches to 0 0, and the function is x square y square divided by x square y square plus x minus y whole square. So here numerator not equal to 0, so clearly it is not equal to 0 when xy not equal to 0 or not equal to same, so not equal to 0. So for this we find limit x tends to 0, limit y tends to 0, and this function x square y square plus x minus y whole square. So if we put y equal to 0 here, this becomes 0, and x tends to 0, finally we get 0. And similarly, if we put y equal to 0 first, and then x tends to 0, x square y square divided by x square y square plus x minus y whole square. So if we put x equal to 0 here, then also we get 0, and limit 0 becomes 0. So these are same, but we get the result if these two iterated limits equal, we may not conclude from here that the double limit exists or not, but there may be another path through which xy approaches to 0 0, but the limit become different from 0. So we find that path. If we take path y equal to x, then this limit becomes limit x tends to 0, and this becomes x square into x square, and this becomes also x square into x square. This is x4 x4, this will be 0. So from here we get this is 1. So for iterated limit this is 0, and for this path we get 1, so different. So from this we can conclude that the limit xy tends to 0 0, this does not exist. So for today that's it. If you like it, please share with your friends and do subscribe. Click on the bell icon. I will cover more for your course, the multivariable calculus. So thank you very much. Dhanyavad.